And this relates to the protein inference problem because you have PSMs that go to peptides, but how do you just match these peptides back to an entire protein, especially when many proteins have redundant peptide sequences? And so there's a number of different ways, different softwares do this. You can see here an example of a number of peptides that may fit with different proteins. So peptide 1 and peptide 2 are both unique and they're both matching only with protein A, so that's an easy assignment. Whereas peptide 3 matches in both B and C, in which case you need to determine the probability. And often it will be based on the number of other peptides that are matching to a specific protein. So both 3 and 4 can match with B or C. And so C is more likely there's more other peptides going with it. But this is a protein grouping, protein ambiguity issue. And another thing to think of is that the amount of uncertainty around any specific peptide, you have uncertainty around your PSM, which wraps into uncertainty around the peptide, which wraps into uncertainty for a specific protein. So all these things end up multiplying. So the higher the number of PSMs for a specific peptide, the more confident you are of it. The more peptides per protein, the more confident you are of it. It is not to say that you cannot have a single PSM and a single peptide identifying a single protein. You can. It's estimated that I think 10 to 20% in large quant experiments may only have a single peptide. But you just need to be careful.
And it's a bigger challenge with proteins that are members of protein families. So if they have closely related members, sometimes it's so ambiguous. I can't say that word today. Apparently, I can't say it. Ambiguous. There, it came out. So if you have an ambiguous ID, you may not be able to tell which one of those two proteins it is. But it's likely that it's one of those two. So then sometimes the search algorithms will actually tell you that as well. So that it's part of a family, but you can't tell which one it is. Yeah.
Exactly. Yeah. So this is something I know a lot of people are really interested in specific isoforms, and they come to me. And the caveat is that with bottom-up mass spec, you may not be able to determine, you may not in a untargeted mass spec manner where you're not doing a lot of extensive purification, really be able to quantitate specific isoforms. Because if it's only one peptide that's different, you need to make sure that's a peptide that you're seeing in the mass spec.